Okay, so your next task is to draw an isotope of the atom you've just done. So I've done, here's my carbon atom. Here's my carbon atom where I haven't drawn the nucleus. Here's my carbon atom where I have drawn the nucleus. I noticed that I haven't actually labelled it, and sometimes in exams they ask you to label it, so I'm just going to write electrons here, protons here. That's inside my nucleus. Okay, so we've kind of ignored this number here, and this is a really important number. This is the atomic mass, and all the mass of your atom is sitting right here in your nucleus. But if I draw this out in a little bit more detail just below, so sitting inside my nucleus is my nucleus. I've got 6 positive subparticles, and we know those positive subparticles are called protons. So this here can only be the nucleus of a carbon atom. Now, why can that only be the nucleus of a carbon atom? And that's because only carbon atoms have 6 protons. If it were 7 protons, well, that would be nitrogen. If it were 8 protons, it would be oxygen. So it's only carbon that has 6 protons. So there is my nucleus of a carbon atom. But we've just said the mass is the heavy part of your carbon atom. Now, let's not forget that we've got our first electron shell, 2 electrons, can only have 2 electrons. Second electron shell, that's a wobbly one, which has 4 electrons. There's the outer shell. That's why carbon is in group 4. But these electrons are so tiny, they barely weigh anything. You can actually get away with it on some exam papers just saying the weight of an electron is so tiny. Tiny is fine. So the weight is everything that's inside the nucleus, but that's 6. It very clearly says on your periodic table that the mass of one atom of carbon is 12, not 6. So what have we got here? We've got our protons, which is our positive, and we've got our electrons. There is something missing. What's missing? We've got our protons and we've got our electrons. Well, the thing that's missing is our neutrons. Think, what does the word neutron sound like? Neutron sounds a bit like neutral. Neutral meaning 0 charge. So neutrons are neutral. Now they're quite large subatomic particles, about the same size as a proton. So where do you think these neutrons might live? Well, our neutrons come along and they live here inside our nucleus. Our nucleus holds our neutral neutrons. So if the mass of a carbon atom is 12, we know that we've got 6 protons. How many neutrons do you think there's going to be? It's got to be 6, because 6 plus 6 equals 12. So there's the mass. So we've got 6 protons and 6 neutrons, giving me a mass number of 12. So you might be thinking this is not helping me to do an isotope, but hopefully it will now, because what is an isotope? It's still got to be carbon. It's an isotope of carbon. So if I'm going to do an isotope of carbon, here's the nucleus. How many protons must carbon have? Remember, 7 was nitrogen. It's got to have 6. It's got to have 6 protons, otherwise it's not carbon. Okay, so it's got 6. My isotope has not lost any electrons. It's not an ion. It's not become a positive ion because it's not lost any electrons, and it's not going to be a negative ion because it's not gained any electrons. So what's the difference then for an isotope of carbon? Right, it's carbon. carbon because it has the 6 protons. It's an atom because it's got a neutral charge. It's got 6 positives balanced out by 6 negative electrons. But the only difference is my isotope has one thing that's different, and that is the number of neutrons. So this isotope of carbon, this is going to be carbon 14. Still got my 6, which is what makes it carbon. This one here we've already said is carbon 12. So if I'm making an isotope of carbon and I'm calling it carbon 14, my mass number's 14, how many neutrons must there be in this nucleus? Just give you a second. Well, it's got to have 8. 8 neutrons, because 8 plus 6, so 8, 9, 10, 11, 12, 13, 14. 8 plus 6 is 14. So an isotope, all you're doing to make an isotope is you need the same number of protons and electrons, but a different number of neutrons. That's the only difference with an isotope, is that it must have a different number of neutrons. It didn't have to be carbon 14. I could have given it 7 neutrons and called it carbon 13. I just went with carbon 14 because that's a radioactive atom. It's radioactive because you've now got 8 neutrons in there. That's making this nucleus incredibly unstable, so it starts to break down, and it's the breaking down of the nucleus that gives that radiation. Okay, hope that helps. So when you're drawing whichever atom you have chosen to draw on that slide, if you want to make an isotope, keep your proton number the same, just change the number of neutrons. So in order to do that, you'll have to draw it out like this, where you put a plus for your number of protons and a little n for your number of neutrons. Hope that helps.